All right, let's take a look at one more discriminant example here because I want to show you what this means. So remember, when we set a quadratic equal to 0, something like this, that means we've plugged in 0 for y, and if we plug in 0 for y, we find the x-intercept. So what we're really solving for is where that graph crosses the x-axis. So 3 different options here. We could have where it crosses that x-axis at 2 spots, where we have 2 real solutions. We could have where it just comes down and kind of touches it real quick at 1 spot. Or we could have imaginary solutions, and these are represented where the graph does not intersect with that x-axis. So that's where those imaginary solutions come from. Okay, so those are my 3 options. And again, just kind of think back to where do those imaginary solutions come from? Well, they come from if we have inside of that radical a negative number, right? If my discriminant is negative, that's where i's are going to happen. Okay, let's see how we can use this real quick to solve a problem to see if a rocket here that we're launching reaches a certain height. So a model rocket is launched. The equation is below. And it says, here we go, there's my function for that rocket. Does the rocket reach height of 50 feet? So if you take a look at my graph here, I have 3 different options for my rocket that is on the black. The first one is it can hit this blue graph twice, right? If this blue here is 50 feet, it could hit 50 feet 2 different times, right? Going up and then going back down. The second option I could have is if that green line is my 50 feet and it comes up and it hits 50 feet right at its vertex, and I would have 1 real solution. The third option here is if that red line is 50 feet and that rocket never reaches it, and that's when I would have imaginary solutions. So I don't have to solve this. I can just use discriminant to see if I'm going to have real solutions or imaginary solutions to see if my rocket is going up 50 feet. So does the rocket reach 50 feet? I'm going to plug in 50 for h equals to negative 16t squared plus 48t plus 6. Now remember, before we solve a quadratic or use the discriminant, it has to be in standard form. So I need to make sure I set it equal to 0 by subtracting that 50 from both sides. So I get 0 equals negative 16t squared plus 48t minus 44. Okay. At this point, it is in standard form. I have a is negative 16. I have b is 48. I have c equals negative 44. I always write these out. That way, for my discriminant of b squared minus 4ac, I can just plug these in without messing up. So I have the square root of 48 squared minus 4 times negative 16 times negative 44. And I'm just going to see what this equals to, see if it's positive or negative. So I just break this down piece by piece. The 48 squared is 2304. And then here, for the part that I'm highlighting here, I just take all of this and I multiply it together. So I do negative 4 times negative 16 times negative 44. And again, 3 negative signs, so I'm going to get a negative. So I'm actually subtracting 2816 here. So inside the radical, I'm left with 2304 minus 2816. I'm left with the square root of negative 512. Now, what that means is I'm going to have the square root of 512i. I have an imaginary solution. So since this discriminant here, since the discriminant is less than 0, I have imaginary solutions, which means I have no intersection for that graph at 50 feet. So we ran into a scenario where we have the red line here is above the height of that rocket. So I would say no, because I just did some great math using the discriminant. The rocket does not reach 50 feet. All right, hope this helps. Back to Mr. Ogden's video. Good luck.